Hey everybody, welcome back. Thanks for joining me once again in Unreal Engine 5. Today I have a more advanced tutorial regarding custom primitive data. Last time I did a kind of an introduction, a scratch on the surface, just kind of introducing the topic. Today I want to show you how you can use that method of custom primitive data to have dynamic materials, to have a more organized workflow, as well as we're going to tackle getting around the limitations of having textures. So let me show you in my own project real quick an example of dynamic custom primitive data at work. So if I hit play, oh, wrong. I'm in the wrong place. Let me go to my hub zone. That's where the dynamic change is happening. Okay, here we are. Start the game. Go get this follower ball. Okay, so now we see the colors. My ball is blue. My water is blue. The lighting is blue. And if I go over this way, this is kind of like a little test zone for myself. If I go this way, we're going to see a slow transition to green. My ball is green, the water is green. And this is all done with custom primitive data. I'm not using any dynamic material instances. This is all very performant, and cheap, and easy to do. So let me show you how I do it. We are going to go through this step by step in our own project and a different project, but I just want to show you a few things before we do that. So for example, my ocean water, let's see. This is my blueprint for my ocean water. It has a construction script. So this is helpful so that when you place that actor in a new level, you can decide what it's going to look like, what the colors are going to be. And I'm going to focus on this node with you guys today, and we're going to look at data tables and structs as well. That's how we stay organized. This is how we do it. So this isn't dynamic change, but it is allowing us to give it a specific color every time we place it into a new level. So let's remember this for ourselves when we do our own. There is another version for just a single float. If I go set custom primitive data float there. So if you just have one float to change, you would use this node. So I hope this is all a little bit familiar from our last video, just looking at these data indexes, how there's a 0 here and a 6 here, and how that all relates to the material setup. This is one of my master materials. It's very simple, but this setup allows for texture use, kind of. So we have a texture here. It's parameterized, so I can change it per material instance, but I still can't change it with the custom primitive data workflow. So we're going to cover all of this. This is a struct I'm using called world palette. I have a light color, my water color, a scattering color, player color, follower color, destro. So you can load this up with a whole bunch of linear colors, or maybe a emissive intensities you want or something. And then in conjunction with the data table, I've got 11 worlds. So this is world 1. It consists of that struct there. And I've chosen colors for all of those different things. This is world 2. I've chosen colors for all of those things. And this is how we stay organized, and how you can pull this window out and open up a level and tweak the colors in real time, and kind of dial in that look that you want, and it'll affect all of the levels that are using this data table. So you don't have to go around and change something in one level and then remember those settings and go to the next level. This kind of keeps you organized, keeps everything the same. So what I did was, if I look at that data table one more time, it has rows, and they're all named world underscore 01 or 02, 03. And so we use a node called getDataTable, and then I've got this is usually a drop down, but I've made it into a variable that is exposed and instance editable, so that when I place my water into a new level, I can tell it which world it's in. So if I click on here, it's in world 01, you can see here. Let me move over to, say, one of these other levels. Oops, wrong one. So this is one of my blue worlds. If I click on the ocean, you can see it's got world 02. That's the color palette for world 2. It's using this watercolor here. And then I have two colors for my water. So I've chosen this one for the second watercolor, which is why you see this one going into here and then this one going into here. And so the way we got that was this out row, we just kind of break S world palette node, and then you can break these pins and plug them in. Make sure your indices are set up properly. So boom, now if I were to make a new level, actually I don't want to do that. Let me show you, say these guys here, they are not blueprints. So when I go into, I have to kind of manually set them through this old method here, not old, but this manual method. And you'll see how this one is slightly different color than this one. For static meshes that aren't blueprints, like I said, you're just going to have to do it that way. But for something like I said, for my water, or say this destro ball, that's what I call them. They're collectibles. There's 3 in a level. If I open its blueprint, we can see it has a construction graph very, very similar to what we just saw. So I'm using the same color to drive a few of the static meshes. We have the ball inside, and then we have this chaos collision or geometry collection. Let me go back here. So same nodes, get the data table. I have a row variable that is instance editable and exposed on spawn. Same nodes. Oops. So that when I place them in a level, I don't have to use that prim thing. I just tell it which world it's in. And in this case, it's in world 2. Just one more example here. This is world 3. It's a different color entirely. And the destros in this one, if I click one and kind of zoom in on it, these ones aren't set actually. So this is been working on it, making changes and stuff. So let's change it together. I probably have to change all 3. So we'll select all 3 and then we'll tell it it's in world 3. Boom. Now they're the color I chose from my data table here. In world 3, the destro color is this. So if I change it to something like that, come back, save it, come back. A little hard to tell, but the color's changed a bit. Cool. I think that's enough of a showcase. Let's go try it ourselves. Let me save it and open up that old project we had. Okay, here we are. First things first, let's look at our material. I went ahead and I added this part here. Last video, you would have seen something like this. We just made a very simple material. We had these parameterized, and then we checked use custom primitive data, and we gave them an index value. So this one's 4, 5, 6. I went ahead and I added a texture sample node. I did parameterize it. It's called texture. Let me call it normal texture, just to be a little less confusing. Put in a few more nodes here. This is for our UV coordinates. If you want to change the UV tiling, I've parameterized that and also given it a custom primitive data index of 7. Then we've got a value here called normal intensity that has an index value of 8, and it's all working together. So now we have normals. I just grabbed a default texture here, so we have something to start with. So that's our new material, and this is the material instance we made last time. The only thing different now is it has this texture parameter. Excuse me. And this is on all of these. And you notice these guys being static meshes, not blueprints. We'd have to go into each of them and tweak their values, their custom primitive data values manually. But let's say I have this one. Can you kind of see, yeah, the texture there? Let's say I want a different texture on this one. So what I did was I made a second material instance. Oops. Just by right-clicking, create material instance. And then I've selected texture and I've changed it here. So if I put this one on, say this one. Let's click this here. Anyway, so there we can play with the normal, the normal intensity and the UV tiling even. So now we have something that looks completely different from this one, but we did have to use a new material instance. And sadly, that is the workaround for using textures with this method, is you just need to make a new material instance. But for every static mesh that you want that texture on, you can use the same, pardon me, you can use the same one. Right? And then you can go in and tweak how it looks. Okay. So what if we had, say, something, I made a little blueprint here. I just put a plane and I added our material instance to it. So if we look at it, we should set some default values for this. Okay. Yeah, that's fine. Pull it out here. Let's make it bigger. There. I'm getting old and I need to see things better, more easily. Okay, there we go. So now we have a blueprint. We have access to a construction script. So let's try to set it up. Set default custom, and we'll use a vector 4. And notice it grabbed the plane automatically there. Index value for the colors is at index 0, so we'll leave it this index at 0. And if I make this promote to variable, we'll say this is color. What you want to make sure is this is a linear color type, so that it's easier to play around with colors that way. If it's a vector 4, you kind of have to know what you're doing. This way we can just kind of pick it from a color swatch. Well, what we do have to do is make it instance editable and exposed on spawn. Oh, what happened there? Okay, I guess I kind of forgot you had to split these pins up. Let's just pull that off first. Go split the pin and then the same here. If we do this, then it should work. Compile and save. There. So now we go back here. Delete that for a sec. Now when we come over here, instead of going to the primitive, we should have this variable here called color. Oh, you can't see it. Let me move this. Maybe it's better I just leave the video there. So now, once I have my springboard selected, we have this variable to play with. We'll make it red. There. Pretty cool, eh? What if we want to change a single float value? We can go grab the plane and let's say we want to play with the metallic nature of it. That's index 4. We can do a variable there, call it metallic, and hit compile and save. Now we should have another variable over here. Maybe if I delete this one and drag a new one in. Oh, you know why? Because I didn't make it. This variable has to be instance editable and exposed on spawn. There we go. Now you can see metallic here. Oh, if I put it up to 10. Ooh, super reflective. You can kind of see the normal there as well. So that's got a texture on it. Let's bring this back down to like 0.5. Maybe you can see the better. Anyway. So that's one way to set them up. What if, but you know, like I have this cool variable, right? But right now I'm clicking and I'm setting it manually to something. What if I want a series, this springboard to look different in every level, but I want to be consistent. So for a couple levels I want it pink, and for a couple other levels I want it blue. So kind of like in my game there I showed you, we're going to set up a data table and a struct. We'll start with the struct. Boom. We'll call it go world color. Open it up. I like to dock pretty much everything I work on there. Okay, so now we have the first variable here. We'll call it springboard color. Make sure this is a linear color. We can save it. And it's just one variable in there, but you know, we're just gonna start there. So when we do this, we have to find our struct here. World color. Say okay. We'll go DT world color. So now we have to add, oh here it is, sorry. Add new row. And let's rename it. Say world 1. You can name it whatever you want, but that makes sense to me. And let's do another row. So we have at least 2 here. There. I save that. And for world 1, we'll set a color for red, whatever. And then world 2, we'll set it to be green. So let's go back to our plane blueprint, a springboard blueprint. And instead of using these variables here, let's reference our data table. Okay, let's try get data table down here, row. So from here we can choose our DT world color, and then you can see it's got the two rows for us to select as a drop down. But what we want is this to be a variable that we can choose, kind of like what we're doing here. I left it as row name, but you could probably just change this to, like, say, world name, maybe. And then we make those instance editable and exposed on spawn. So now, let's just see what that looks like over here. So now we have these two variables we had before, and we also have this world 0, 1. That's the default. I think we can get rid of these now, right? We'll leave that one. Don't need the color. What we can do is we can, can pull it off and say break the struct. And if we had more than one row, you'd see all the rows here. Maybe we should do that, eh? Let's add to our struct. We'll add another variable, and let's make this one the metallic one. And that one was a float, so we'll change it to float. Then when we go to our data table, we should see the color and then this metallic thing. So for world 1, we'll have maybe red metallic things, and then this one it'll be green, kind of softer with a 0.2 there. Now we see this pin pop up as well here. So we can get rid of this metallic pin, put that in there. We can break this, split it, and then plug these in here. Bada boom, bada bing. Look at that. It's red, that color we chose for world 1, and it's metallic. So if we change this variable over here, notice those other variables are gone. Oh, the metallic one is still there. Why is that? Because we left it over here. Let's delete it. So now we're just left with this one here. If I change it to 2, boom, it's green and it's less metallic. So you can imagine having a bunch of these in one of your levels, and you can just go to all 3 and tell it world 0, 1. And then when you place them in your next level, you just change it to be whatever you want. So that's how we stay organized with structs and data tables and construction scripts. Okay, so let's make this dynamic. I'm going to come into here, event begin play. Let's do set timer by event. We'll go custom event and change color. We'll set this to loop and trigger it every, say, 5 seconds. From here, we're just going to do the same thing. Set default primitive data vector 4 on the plane. Data index is 0, which is great because that's the index of our color here. Come back to our springboard. And let's split that up and we'll say float random float in range, 0 to 1. And we'll duplicate this a few times. There. And we'll leave this value as 1. So hopefully we should see the color of this thing change every 5 seconds. So let's test it out. 4, 5, there we go. Okay, but that is just a little demonstration on how we're using custom primitive data to change values at runtime, and we're not messing around with material dynamic instances. Okay. Okay, I think that's all for today. Let's wrap up. Let's summarize what we did. We've got material instances that are kind of unique with textures. That's why we have 2 down here. And so that's working around textures. We have figured out how to use construction script here, exposing our variables so that we can place these in different levels and set them to different colors. And if we want to get really organized, we're going to use data tables and structs so that everything stays the same color and everything's kind of click, 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 and it changes throughout all your levels. And then we went one more step further to just demonstrate how we can change these at runtime by a simple kind of looping timer event here. And I would suggest if you had probably a purpose, you wouldn't use this random colors, but you could use random for something if you wanted. So that's it. That's my advanced kind of tips and tricks for using custom primitive data. I think I'm only using a handful of material instances in my game, and I'm covering hundreds and hundreds of variations. So it's really, really powerful, really cool. If I missed anything, if I skipped anything, if it wasn't clear, you can leave a question in the comments below. Otherwise, I hope you all have a great day, and we'll see you next time. Cheers.